Hello, welcome to S Chemistry. Myself, Dr. Suhas Gaudi, and today I will be teaching BSc 5th semester Physical Chemistry course on colligative properties of dilute solutions. So, this is lecture number 4. Here is the outline. I will take the point that is depression of freezing point. So, how in freezing point depression will come? So, let's start. So, in right hand side, as you can see the graph, that is vapor pressure versus temperature, that is shown here. So this graph represents the relationship between depression of freezing point and lowering of vapor pressure. So they have plotted vapor pressure versus temperature. So as you can see here, curve ABC represents the solvent graph, whereas in solution 1 uh, represents this curve that is in the green color. So if you add the salt or solute into the solvent, you will observe this graph. So slightly lower, at lower vapor pressure, it will start freezing. So the vapor pressure of a pure liquid changes with temperature as shown by the curve ABC. So as you go down, as you reducing the temperature, so at one point you will find this point B, that is represents the freezing point of that solvent. Further, as you decrease the vapor pressure, your freezing point also will shift to the left hand side as shown in this graph. So the vapor pressure of pure liquid changes with temperature with sharp break at B and indicating that freezing point of the pure solvent, that is TF. Vapor pressure curve of a solution 1 of non-volatile solute in the same solvent meets the freezing point curve at F. So this point F represents the freezing point for the solution 1. So T1 is your freezing point for the solution 1. So here the depression of freezing point represented by the symbol delta T or delta TF is the difference between the freezing point of the pure solvent TF and the solution T1. So they are comparing this ABC graph with the solution 1, that is with green graph. So as you have two different point, so TF minus T1, you will be having this difference, that is delta T. That delta T represents the depression of freezing point. If you add further more solute into the solution 1, resulting one more concentrated solution, that is solution 2, with vapor pressure meeting the freezing point, that is C, indicating further freezing point lowering to the T2. So here if you add more salt in solution 1, you will get graph solution 2. So this T2, that is the freezing point which is lower than the actual solvent, that is TF. So moving further, so this graph or depression of freezing point is only applicable for the dilute solution. So for dilute solution we observe this, for that is solution 1 and solution 2, we observe this graph. So here FD and CE are the approximately parallel straight line, and BC also a straight line. Since BDF triangle BDF is similar to the triangle BEC, and this BDF. So these two triangles are similar. So from similar triangle property, you can compare DF divided by EC. So this will be always equal to the line BD divided by BE. So above triangle is BDF and below triangle is BEC. So if you compare this line, so you will get TF minus T1, so that is DF, that is divided by EC, that is EC. So this line represents the TF minus T2. So as you can see here. So in similar way, so uh, BD is nothing but your P minus P1 and BE is nothing but your P minus P2. So in that way we have taken here. So where P1 and P2 are the vapor pressure of solution 1 and solution 2 respectively. Hence, depression of freezing point is directly proportional to the lowering of vapor pressure. So from that, so delta T is directly proportional to the P minus PS, that is nothing but your vapor pressure. So that is lowering of vapor pressure due to salt. So this equation 1 says everything about the depression of freezing point. Since vapor pressure is a colligative property, in similar way freezing point depression is also colligative property, because in first lecture we have seen that this vapor pressure, whatever the lowering of vapor pressure, is a colligative property. So in that way also your temperature, that is freezing point depression, is also colligative property. So here are the references for the images, and for the content you can follow these three books. Here we come to end of the lecture. Thank you for kind listening. See you in next lecture. Till then, happy learning.